Many teachers tell me that they don't have time to spend on probability and statistics when they teach it. But this is something that's very important in the world and is used all the time. I think we want to make sure that we stress the foundational information for this, at least with students, so that they're ready for more advanced study at a later time. As with all math concepts, we want to make sure we take lots of time right at the beginning so that students understand what this is all about. I mean, what is it? What is probability? What are statistics? Where do we see them? We want to make sure that that foundation is very well set. And we want to start at levels that students can easily understand. For example, when we're introducing probability, we want to start with the word probably. We might say to students, you want to stay overnight at a friend's house Friday night. Who are you going to ask for permission? And the student might be thinking in their own mind, well, gee, if I ask my mom, oh, she always says no. If I ask my dad, he might say yes. Well, maybe I should ask my grandma, and she would talk to my mom. So we want students to be thinking about who would probably say yes. And what does probably mean? Does that mean they will for sure be able to go? It's really just a prediction. It's a guess. When they get an answer, and they either get to go or don't get to go, then we know what actually happened. And when things actually happen, that takes us into statistics. So probability is predicting something that might happen, and we can record that mathematically. But statistics means we're actually looking at what did happen, and we're organizing that information in a way that makes sense to us. When students are learning about probability and statistics, it's important for them to have many opportunities, for them to do probability and statistics in many ways, many times, to set that foundation. One of the first things we want to make sure that students know is that, like fractions, when we deal with probability, we're talking about the total chances. What are all the different things that could happen? What's the total amount? This is very similar to fractions. And like fractions, once we get a result, sometimes that result can be simplified. So we want to make sure, again, that we relate one concept to another, something new that students are learning to something that they've already learned. And we want to keep stressing this in all the activities that we do. We want to use that language. What are the chances of this happening out of all the possible chances that there are? We need students to hear that over and over again. And we want to start with very simple things. For example, if my teacher brought cookies as a treat for us, and each one of us gets 2 cookies, and there are 10 groups of Oreo cookies, and there are 10 groups of chocolate chip cookies, and the teacher has us line up and come up and pick the ones that we want. If I'm thinking that I really want Oreos today, they are really my favorite, and that sounds really good. And when I get up near the front of the line, if there are 3 people ahead of me, and there are only 4 groups of the Oreo cookies left, what are my chances that I'm going to get them? Well, there are 4 people, there are 4 groups of cookies, so my chances are 4 out of 4, 100%. I don't have to worry. If it were fewer cookies left, then I might have to calculate differently. So we want students to be thinking about what this chances thing really means. A fun way to introduce probability after we've done a little work with the language and the vocabulary is to just ask students to play the game of rock, paper, scissors. And we want to make sure that we don't assume that students know how to play this game, because many don't, and many play it differently. So we want to make sure we take a little time to give them some very basic instructions. But after we do that, let's just let them play the game. Let's just say, okay, we want you to play 15 rounds of rock, paper, scissors with your table partner, and we want you to record who wins each round and what they win with. Do they win with rock, do they win with paper, or do they win with scissors? Students' results might look something like this. We asked them to play 15 rounds. They might say, well, we had 4 ties. We had 4 games where rock won from one of us or the other. We had 3 games where scissors won, and we had 4 games where paper won. And we could have a table on the board, and we could have the students come up and put how many won each time. And we could let this emerge for them. We could let them see and think about, how does each one of these win? And after we just have them do this with very little mathematical instruction, then we might put these options on the board, and we might say, okay, what are all the possible outcomes? Well, you could both choose rock, you could both choose paper, you could both choose scissors. And in that case, we have a tie, right? And then we can look at all the possible other alternatives. It could be rock, paper, or rock, scissors. It could be paper, rock, or paper, scissors. It could be scissors, rock, or scissors, paper. And we can list these on the board for students to see. Then we can come back and examine how many times each one of these allows us to win. So in this situation, paper, rock, paper, scissors, rock, scissors. So what happens? Well, if we choose paper, it looks like we can win 2 times. It looks like we can win 2 times if we choose rock, or 2 times if we choose scissors. So now if we look at all the possible outcomes, how many possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 possible outcomes, and out of those outcomes, we can determine how many we would win if we choose a particular thing. Using something like this game that students already know and they already enjoy doing is a very valuable way of introducing the idea of probability, of predicting by looking at all the possible outcomes what might happen. We can also teach probability by flipping coins. And some teachers don't like to use coins because of the noise in the classroom. I personally always loved that noise, and I think kids really enjoy working with real coins. So we could say to our students, if I flipped a coin 10 times and I get 6 heads and 4 tails, what are my chances of getting heads on the next flip, and why do you think that is? We might pose that question first before we do an activity, or we might wait and pose that question after we do an activity. For example, we might say, I want you to flip your coin 30 times. Each one of you flip your coin 30 times, and I want you to record how many times you get heads and how many times you get tails, and then we're going to put all that information on the table up on the board. And then we have students do this, and they enjoy it, and they record how things are going. And when they're finished, they compare with their table partner. How many heads did you get? How many tails did you get? And then we put all of that on the board so we can see it all at once, and then we look for patterns. Now, what we're probably going to see is that we have about the same amount, but maybe not exactly. And then we can talk about what are they noticing? What patterns do they see? And then we can go back and talk about the math. If they're flipping the coin 30 times and they're flipping it by themselves and it's just one coin, they can get either a heads or a tails. So there are 2 possible outcomes. Getting a heads or a tails is 1 chance then out of 2, or a 50-50 or a 50% chance of getting heads or tails. And then we can go back to our first question and we can say, okay, so I actually flipped my coin and I got 6 heads and 4 tails. What am I going to get next? And some students might for a minute think, well, heads is turning up more, so I bet I'm going to get heads. And we want to remind them, what are the total possible chances and what are the mathematical possibilities of each one? And they should be saying no matter how many times they flip this coin, the chances are 1 out of 2. It's 50-50. At this point, we can teach the difference between mathematical probability and experimental probability. So if we look at our table on the board again, we can say, mathematically, each one of you should have gotten 15 heads and 15 tails when you flipped your coin 30 times, but you didn't. And that's the experimental part. What happens in the world doesn't always match exactly our mathematical expressions. And if we want to, we can talk about why do we think that is? What factors might come into play that could affect the outcome? Another fun activity for teaching probability is putting stones in a cup. So I put stones in a cup and I have something over the top so students can't see what's in the cup. And I have them work with a table partner. And I say, I want you to pick 1 stone out of the cup and look at the color of it and then put it back. But you need to make sure you don't look at anything else in the cup. Nobody can look in the cup. So one person holds the cup, the other person draws a stone out of the cup, and they switch back and forth, and they do this 5 times or a few times or however many times I want them to do it. And I have them record what they get. So let's just say that we had students do this and I had them pick a stone out 5 times and each time it was green. Then I would say to my students, well, what do you think that means? What does that tell you? And students might say, the stones are all green. Or they might say, well, there must be more green. Or they might say, well, maybe the green one's different shape. They might have all kinds of possible answers for why they're picking green. And then I might have them actually look at the stones in the cup. And I would say, okay, look at the stones in the cup. Dump them out on the table and look at them. what do you think your chances are of drawing each color? If there are green, blue, and clear stones there, look at how many there are. What do you think your chances are? And I might keep this very general at this point. And they might say, well, there's way more green stones, so I think that I have more of a chance of drawing green. Or some students might have misconceptions where they might say, well, there's only one of those clear ones, and maybe I'll draw that one, maybe that's the one that will show up. So this is a time for us to just get at student thinking. Then we can get to the math, and we can say if there are 20 stones in this cup, and if 15 of those stones are green, what are our chances of drawing a green stone? Well, it's 15 because there are 15 green out of 20 total. And then, like fractions, if we wish to, we can simplify. But for many students, it's enough just to have them be thinking 15 chances out of 20. That's a lot of chances. Then we might talk about the chances of drawing a blue stone. If there are 4 blue stones in the cup, and there are 20 total, because we always put these back when we draw them, then our chances of drawing a blue stone are 4 out of 20. Or again, we can simplify it if we wish to, or we can have students who understand that well simplify it, and other students stay with the 4 out of 20. What are our chances of drawing a clear stone? Well, there's only one, and there's 20. So they can look at all of these and say, now let's go back and do some more experimental drawing and see if it matches our math. What should happen? And of course they should be saying, well, we should be drawing a lot more green stones. But if someone draws a clear stone, it's always kind of fun in the classroom because the classroom sort of erupts in, I got a clear stone, and the chances are only 1 out of 20. So they can see again that experimental probability does not always have the same results as mathematical probability. Another fun way to work with probability with younger students is to roll dice. And just like we were doing with the stones or the flipping of the coins, we can say to students, we want you to roll these dice 36 times, and we want you to record the number that you get, the sum. So you're going to add the two together and determine what the sum is, and you're going to keep track of that. And we're going to do that 36 times. And we're going to see what we come up with. And again, we can collect this information on the board, and we can let the mathematical laws just emerge from the student data. So by looking at this picture here, this diagram, this chart, you can see, of course, that to roll a 2, there's only one possibility, and that's to get a 1 in both of these and add them up to get 2. To roll a 3, there are 2 possibilities because we might get a 1 on one die or a 1 on the other. And we would continue this process, having students analyze the results that they got and then be thinking about, well, why would that be? At that point, we can give them some time to work with table partners and say, what are all the different sums you can get? And how can you get those sums? And so they can go through, again, we haven't shown them this chart yet, they can go through and they can say, okay, how can we get a sum of 2? How can we get a sum of 4, 5, 6, 7, all the way down? And when they do this, of course, they're going to realize that there are more ways to get a 7 than there are any other sum. So they will come up on their own with how many possible ways there are to get each of those. And when they're done with that, then they can count up how many total possibilities are there when they do this, and they will find out that there are 36. So to roll a 2, there's only one possibility. So my chances of getting a 2 are 1 out of 36. If I go down and look at my chances for rolling a 7, I have 1, 2, 3, 4, 5, 6 possibilities. So my chances are 6 out of 36. And just as we were talking about with fractions, we could have students simplify that if they're ready for that. Or for most students, we might want to just stay with 6 out of 36 because they can see that easily. There were 36 possibilities, 6 out of 36. It's something they can picture. We can also practice probability with a spinner. This is something else that students really love to do. There are spinners out there of all kinds, spinners that have sections that are the same size, that are different sizes, different colors, and we can use them in different ways. With this spinner here, we might ask students, what is the probability of spinning and landing on an odd number? So what do we want them to think? Well, what are all of our possibilities? 1, 2, 3, 4, 5, 6. There are 6 total possibilities. What are the chances of spinning on an odd number? It could be a 1, it could be a 3, it could be a 5. So our chances are 3 out of 6. Again, we could simplify. What are the chances of getting an even number? Well, it could be a 2, it could be a 4, it could be a 6. So again, our chances are 3 out of 6. What are the chances of spinning and landing on a 5 or a 6? 2 possibilities out of 6 possibilities. What about spinning a 5 or smaller? 1, 2, 3, 4, 5 possibilities out of 6. And again, we can have all of these questions listed on a task list or on the board or on the smart board, and just let students work with this and have them talk out loud so we know that they're thinking properly about what probability is and how we find it. Teaching things that are a part of statistics like mean, median, and mode can also be done with actual objects in active ways. I remember many students telling me that the way they learned to find a mean or an average was the teacher would say, you need to add up all the numbers and divide by how many numbers you have. Well, mathematically, of course, that's correct. But what does that mean to students? Does that mean anything to them? Do they understand what they're doing or why they're doing it? A fun way to do this is to have students build towers. Sometimes I will ask students, build a tower that shows me how many people are in your family. And I always let students decide who's in their family. Their family can include grandma and grandpa. Their family can include the dog or the cat. They get to decide how many people are in their family, and we don't ask questions about that. So they build their towers, and in maybe groups of 4, they might compare their towers, and they might find something like this. Maybe the towers are all different sizes. Maybe the towers are the same in some cases and different in some cases. So they can talk about why is their tower that height, and they can bring in a little personal information. What we can do then is we can use the ledge on the whiteboard or a table, and we can have students line up their towers. Everybody in the class brings their tower up and lines it up. And then we can say to the students, what do you notice? And of course, they're going to say some towers are much bigger, some towers are much smaller. Wow, look at that tower, it's the biggest in the class, or this one has only this many people. And then we could say to students, why don't we put them in order? So then, on the chalkboard ledge or on the table, we actually have these towers lined up from tallest to shortest or shortest to tallest, something like that. And then we can ask students, what do we notice? What if we wanted the towers to all be the same size? What would we have to do? And students can say, well, some people would have to take from their towers and give to other towers. Or, at this point, we could have students come to the middle of the room, all around a table, and we could say, let's take apart our towers and put all of those on a table. So they take their towers apart, and then we just have a pile of cubes on the table. And then we rebuild them. We're going to rebuild them so they are the same size. That's what we're doing when we find an average or find a mean. We can also, when the towers are all lined up on the whiteboard here, we can talk about the sizes that repeat. How many towers do you see that are the same size? We can have students look for that. Maybe they find 10 towers that have 5 people in them. Or we could say, which tower is in the middle? How many towers do we have on this side and this side if we look for the tower that's in the middle? Now, if we have an even number, of course, that's going to be more difficult, and we're going to have to talk to students about how we would figure that out. If we have an odd number and the towers are in order, then one of those towers is going to be in the middle. Then we can introduce the language. We can say the mode is the one that appears the most often. The median is the one in the middle. The mean is where we leveled off all of our towers and made them the same. And students will remember what they did. So when they look at these words, they won't just be mathematical terms. They'll be something that they have a picture for, something they can visualize. A fun way to teach some parts of statistics is to have students gather original data. This can be done very easily by having class surveys or grade level surveys or even surveys of a whole school where students are actually going out and collecting this information. They can start with something as simple as the eye color in their classroom. How many people have blue eyes or brown eyes or green eyes? They can send out a short little questionnaire of favorite foods or favorite places to travel. They can collect information about birthdays. Before we have students do this, however, it's good for us as the teacher to model some kinds of statistics, some things we can do to gather data. For example, we might have living graphs. I could write the months of the year all across the whiteboard, and I could ask my students to come up and stand in front of the month that represents their birthday, for example. And then I would see how long the lines are. So students could look around and they could say, gee, nobody has a birthday in August, or we have the most birthdays in October. They can see the lines, they can count how many people are in the lines. They might even notice that some lines look longer than others because people are standing farther apart, or some lines look shorter because they're closer together. And that would help them understand that when we represent data, we need to make sure that things are the same size. At that point, we could give students blank pieces of paper, just white paper, and we could say, I want you to represent what we just did, either with the Post-it notes or with the living graph. I want you to create a visual representation of what we just did. This really makes students think. They have to think about, gee, what am I going to put on the bottom? What am I going to put on the side? What are the labels going to be? How am I going to organize this in such a way that it makes sense? Too often, I think, we give students too much help. Grid paper, we give them ideas. Well, let's put this on the x-axis and this on the y-axis, and your label should be all of these kinds of things in the same distance. I think we want students to be discovering those things so that it makes sense to them. And students might represent things in different ways. They might have experience with bar graphs or line graphs or dot graphs, and they might do things differently. And that's a good thing because then we can compare. After they've done this, then we can talk about some standard things we want them to learn and understand, and we can use student models to do that. After that, we might get to the point where we actually give them existing graphs and ask them to read them. But by that point, they've had a lot of practice with statistics. They've thought about it. They've thought about keys. They've thought about labels. They've thought about all the important things that go into making graphs so that they are very easy to read. Through all of this work, we want to make sure that we're emphasizing to students that we use graphs and tables and other things like them to represent statistics because they're easy to see at a glance. For example, I can look at this right away and I can count how many things there are in each row. And it's very easy to see which is the most, even though they're different sizes. And students should notice that as well. Students could look at this pie graph and they could say, well, gee, the red represents math, the blue science, the green social studies, the orange music, and the purple reading when we had a survey about our favorite subject. Gee, it's very easy to see that the red is the biggest. That means most students in our class like math. And if we want to, we can add the numbers, we can add percentages, we can do all kinds of different things with a very basic pie graph like this that can be differentiated for students at different levels and different abilities. But the message is the same. These graphs are a visual representation that make it easy to see results. Probability and statistics are used in the world all of the time, and we need to make sure that we don't skip this very important topic and that we teach how it's used in the world. We can talk about temperatures and weather patterns. We can talk about things like the lottery and gambling. That might be a controversial subject for some students, but I think it's important that they understand the risk in some of these kinds of things. We can talk about the stock market. When people are investing in the stock market, they're taking a risk. They're making predictions. They're looking at probability, and they're keeping track of the data, which is statistics, and that's helping them make what they think are good decisions. We can talk about things that interest students, like batting averages or other statistics involved in sports or other activities that they might be involved in. As with all the math that we teach, we want to make sure that we're making connections between the work that we're doing and work that we've done in the past. So as we look at probability and statistics, we're going to find connections to fractions and other things that we've taught. Making those connections so that students understand that math concepts do not happen in isolation is very important. Math is everywhere in the world, and I'm not sure we can stress that enough.